Hello guys, Cyprien from Feaforall, and today we'll test new things. So as an engineer, you should always, test new codes, try new tools, and discover what you can do. Because there's a range of tools that we are not aware of, especially open source codes, which are, mainly used by, I know, professors, scientists, and sometimes you will find a pearl into those. So last week I was talking about the LBM method, the lattice Boltzmann method. So I was thinking, you know, now that I've done this introduction, why not test a bit some of those open source codes that are out there? That way we can have practical, trial at some of what those codes can do. And it's also fun to see the code and to try by yourself new things. So let's go. Let's try that. The code I will be testing today is Palabos. So I asked my friend, the Dr. Nicolas Maquignon, who told me that if I had to try an open source code for LBM method, I could try this one. So I trust him that this code is pretty good. And we'll see. I have absolutely no idea of what I will get. So it's a code developed by the University of Geneva. And let's have a look at the website before I actually try to install it and run it. I've never used this code before, so this will not really be, installation tutorial or anything like that, or telling you how to use it, because I don't know how to use it either. I'll just be trying out this code and see what I can do with it. So let's have a look. So this is computational fluid dynamic CFD code, which is based on the lattice Boltzmann method. It is straightforward to use. Well, that's what is written, right? And Palabos stands for Parallel Lattice Boltzmann Solver. Okay. It is written in C++. It has practically no external dependencies, which is good, because when an open source software has a lot of other dependencies, it's even more difficult to install and everything. So this should be quite easy to install. We'll see. And there are some interfaces in Python and Java for that, which makes it easier to rapidly prototype and develop CFD application. Well, that's the thing. They always tell you it's easy, but how easy is it when you have to write everything in C++, right? So everything depends on, what kind of person you are. If you are a C++ genius, maybe this is very easy for you, but anyway, intended audience covers scientists and engineers with a solid background in computational fluid dynamics and potentially some knowledge in LB modeling. And it's freely available, which is great. So let's have a look a bit at the other pages. Get started, publication. Let's look maybe, I don't know, the publication to see what they have. Okay, so articles about this. Oh, wow. There are a lot of articles. That software must be good. It has been used a lot. So more than 300 papers about it. Well, this is probably a really good code. Now let's have a look at the gallery, maybe. So what do they have? Free surface, particle and bubbles, cellular blood flow, and porous media. Free surface. What can you do with that? Free surface, always very fancy. Wow! Oh, this is an amazing picture. Can you really do that? Oh, amazing. This looks so realistic. It's great. What else? Particles and bubbles. Oh, blood flows of blood cells. Cool. Very cool. Cellular blood flow simulation. So I guess it's something used a lot in medical application, probably. Okay, so blood cells again. And porous media. Okay, I see that this is some kind of bone maybe. So this is probably something used for medical applications, because porous media in the body, blood cells, etc. So that's cool. So okay, so now I'm excited. Let's have a look at the other stuff. How to download it. So we have documentation, tutorial, and lattice Boltzmann. So let's go to download first, and then maybe we'll dive a bit in the documentation. Okay, download latest version. Go to Git repository. Our instruction: short installation. Compile one of the example by changing and typing cmake and make. Okay, I see. Well, I'll try that. So let's keep that in mind. Detail installation instruction, check your user guide. Okay, so I'll have to have a look at the user guide maybe. Okay, so let's go to the GitLab repository. Okay. And I guess that if I want to get this code, I need to clone that with either SSH or HTTP. So let's try simple HTTPS. So I'm copying that, and then let's go into, oh, by the way, I'm on Mac OS, so maybe I should check first if this works on Mac OS. Otherwise, I'll have to switch to Linux maybe. So do I have somewhere where it's written? Probably here, if it's written, if it's compatible. Installation, Debian, Windows, Linux. Do I have somewhere written if it can work on macOS? Compile an example, documentation. Let's search for the macOS word. Not written. Okay, well, you know what? I will try, and we'll see. If it doesn't work, well, I have to switch to something else. Like I told you, this is really experience for me. So let's go back, and let's create, I don't know, let's create a folder here called Palabos. Let's open a terminal into here. So maybe I'll just open my terminal, cd in my desktop, and Palabos. Okay. And oh, sorry. Yeah, I forgot. I'm using iCloud, so maybe it's not a good idea to put that on the desktop. That's a bit. Let's put that, I don't know, in my key folder. So okay, so let's put it here. Maybe mkdir Palabos. Okay, cd Palabos, and now let's do a git clone, and let's see if I'm able to clone this code. And this code should appear somewhere in here. Yeah, so I think it's already downloaded. That's surprising. Okay, so the way to use that, so maybe I'll have a very quick look to the user documentation, just to say that I opened it before I tried anything. Documentation or tutorial, documentation maybe. And user guide or developer guide. I guess user guide is for beginners. And Oh, so there's a lot of stuff into that. Oh, and I see the word Mac OS, which is good. So that means that it should work, right? Okay. What is Palabos? Okay, so I guess I need to read that more carefully, so we'll not do that here. But I'll definitely download this and take some time to read. Just for fun, what is implemented in Palabos? Let's have a look at the physics. So weakly compressible non-thermal Navier-Stokes equation flow with body force, thermal flows with Boussinesq approximation. So this is for natural condition flow. Single component multi-phase fluid, multi-component multi-phase fluids, free surface flow. Well, there's a lot of stuff. And static Smagorinsky for turbulence. Then we have basic fluid models. I don't know what that means. BGK or something. All kind of boundary condition. Type of grid implemented. So if you watched my video from last time, you know what is the lattice grid, you know. And there's D2Q9 that I talked about in my video. And then they have D3Q13, 15, 19, 27. So different kind of lattice. And I guess more you want precision, accuracy, more you'll need to have that. So parallelism, of course, because LBM is used for parallel application. Post-processing, so produce GIF images and data can be saved in VTK. Okay, so basically I'll probably use ParaView, which is good. By the way, if you don't know about ParaView, I have a series about it on the channel. So you can go from zero and learn ParaView using those videos. And getting started. Okay, a lot of stuff. Well, let's have some fun right now. Let's go into the folder and let's have a look at what we have here. And so we have some examples, and I think this is what I want to start with. So we have some tutorials, tutorial 1, 2, and permeability, benchmarks, cavity benchmark, okay, showcases. Oh, there's a lot of showcases actually, so it's pretty good. Probably try some of them. So code with particles, moving wall, all this, very cool. I guess the best is to start with tutorial 1 maybe. So if I remember what was written on the page, it's all in C++, and the way to use that is to build all of this. So you see you have the cmake lists.txt. So in this file, you have basically the instruction to build this code. And so you need to have cmake installed. If you don't have cmake on your computer, you'll have to look for cmake on Google and install it. In Mac OS is probably pretty easy to install with brew or something. Let's go into build and let's go into here. How can I open that in? I know how to open it in the terminal. cd Palabos, and there I'm in example tutorial 1 in the build. Okay, and now I have to use cmake and ... So that means that I'm using cmake on the files which are on the top folder from this build, so in the tutorial 1. Let's try if this works. And I'm seeing something generated, so it should be working. And now, so let's see, I have C compiler. By the way, if you have CMake and it doesn't work, you probably have to install Xcode on Mac, because Xcode I think comes with the C++ compiler and all the stuff. So installing Xcode will get you all that. Now let's try make. And now it's compiling. So at least seems to be working up to now. So it's always some kind of challenge to get this kind of thing working. Maybe let's have a look at some of those stuff. So we have tutorial 1.1, 1.2, 1.4, and I guess this is the input file. So this is the C++ input file. Let's have a quick look at how it looks. Wow. So yeah, it's a pure C++ file. So you have the imports, you have namespaces, you have defined initial density at center. So there are comments in this file which are good. At least it tells you what this code is doing. But I guess if you want to be able to use that, you need to have a minimum knowledge of C++, which I have. So I guess I should be able to use it. And if it's easy as they were saying it is, I should be able to get something. Oh, and it's compiled, right? Awesome. So let's close that. And you see that in this folder, I have now a tutorial 1 executable which has been generated. So I guess let's try to run this. And with a bit of chance, this should launch something. Oh, and it started to write the GIF file. So it's basically directly running the solver. And maybe it's, oh, it's okay. It's generating here. So as you can see, it works, and that's cool. That's very cool. That's actually the first engineering code that I'm running on Mac OS. So I'm pretty confident it should work on Linux pretty much in the same way. It's written it should work on Windows, but I don't know. So let's have a look. So this is clearly just a test or something, because it how can I open all that? Let's open this and maybe can I open everything at once? Or maybe I think there's a view mode or something with gallery. Oh yeah. How does this work? Okay. So there's some kind of pressure, I guess, which is put here on this area, and then this kind of spreads in all direction, creating waves. So this is probably some kind of fluid acoustic analysis. Now, what you see here is pressure, I guess, acoustic pressure, and you see the waves of pressure which are going around the walls and coming back and merging together. So the blue part is kind of the bottom of the wave, and the red part is the top of the wave. Okay, so at least it works, and I think it's pretty cool. Let's try another example just for fun. Sorry. So let's try another example. I don't know, maybe showcase or benchmark. Cavity 3D. So Cavity 3D should be clearly more computer intensive. I think right now I'm running with one CPU. Probably I'm not running in MPI. I don't know how to run that in MPI. I'll probably have to look at the doc. I don't know everything just like that. So showcases, tutorial, showcase, maybe let's have a look at those showcase. Cylinder 2D, what can be cool to try in 2D, maybe multi-component 2D. Cavity Poisseuille. Let's try the Bouzenesque thermal 2D maybe. So let's try build. So cd. Now I'm in the showcase and I'm in the Buzinesk thermal 2D. Okay, build. And let's use the same way, cmake dot dot. And oh, I see, by the way, that I have MPI installed, so should be working, but I just don't know how to launch it with MPI. Make maybe MPI run, but I'm not really sure about that. Okay, so it's compiling. Rayleigh burnout 2D. So again, okay, so you have a description. So a fluid constraint between a hot bottom wall and a cold top wall. Lateral walls are periodic. Using the influence of gravity, convection rolls are formed. Thermal effects are modeled by means of a Buzinesk approximation. The fluid is incompressible and the influence of the temperature is visible only through a body force term represented buoyancy effects. The temperature field obeys an advection diffusion equation. So it's a CFD thermal simulation with gravity and buoyancy. So a natural convection type of simulation. And wow, the code looks pretty complex. I don't know how you can say this is very easy, but you know, I see that, I'm like, wow, what is that? Write VTK, write GIF. It's very close to the core of the code, right? You have to be very clever to use that. So let's okay, I see it's compiled. Let's go back and let's have a try. CD. So same, what's the name of the executable? Rayleigh burnout. Can't read in common input line. There are no common structural input file should be okay. It's RA, so it needs some kind of input variable here, RA. So I guess it's the Rayleigh number or something. And there are some data here, so let's open that. Maybe they will tell me what kind of Rayleigh number I should take. And oh yeah, okay, Rayleigh 100. So I guess I'm gonna try with 100 at first. So 100. Let's see if that works. That seems to work. Writing VTK, writing GIF. So here you have the VTK file as well. And okay, so we see initial, so you have gradient of temperature, hot at the bottom, colder at the top, periodic at the boundaries, and this temperature is diffusing. And oh, it's already completed actually. So I guess if you change this number, maybe I don't know, but 1,000, you'll get different results. So I see the files are updated. So I'm seeing that each increment I get temperature and I get velocity. You know, the name of the file is u something, so I guess it's velocity. So it's a velocity generated by this kind of temperature flow, and there is a interaction between flow, gravity, and temperature. Okay, it's done. So there's a small difference, because the flow seems to be a bit in this direction here, like that. Okay, so interesting. So, and I have some VTI files that I guess I should be able to open with ParaView. So cdtmp ParaView. Let's launch ParaView and have a try at that. open. And I have those VTK file. Okay. And I know what it's doing right now. Open. Maybe I should open them one by one. Doesn't seem to be working, so I don't know if it's my installation of Paraview which has a problem, or VTI file is special and need a special plugin or something to be open. Well, I guess I'll have to investigate that. And I guess that's all for this video, because that was just some kind of test to fiddle around with new kind of stuff that I don't know, to learn more and to discover. And I hope that this also useful for some of you watching, and maybe if I become good in this, I can do some tutorials about it, but we'll see. For the moment, I'm looking at this file and I'm thinking it will take some time to be able to use this. So thank you again for watching. If you have any comment, if you have any question that I can answer, please leave it either on this video or on the blog. I'm always happy to listen to whatever you want to share with me. Thank you very much, and goodbye.